So let's switch to domain modeling. So now we have a set of these maps. And what we do in domain modeling is we turn to college instructors and we basically said, okay, here's all the knowledge that you're trying to convey. Now, what do you want students to do? Tell us what you really want them to do. You run into them 10 years from now in the supermarket. What do you want them to be able to remember from your class? That's what we asked them. And guess what? They wanted them to be able to use the knowledge. So once they told us the ways they wanted students to use the knowledge, and I'll show you what those look like in a second, then we said, okay, when they are doing that, when they know those things, what parts light up on the map? That's the student model. That's the student model. What's in the student's brain when they're doing what you want them to do? So they told us that. And then we said, well, how do you know? How do you know they're doing it? What can they show you? What can they produce? And that is the task model, what we call the task model. And that is how we're going to design our assessment items. We're going to create tasks where people get an opportunity to show us that they know it. Then we do pilot testing, and we get the statistical analyses done. And basically, we're just trying to find out, do we have the scale right? I mean, how can you tell the most expert student, what does the highest score really look like? What does the lowest score look like? What is happening in the middle? That's the scaling part. And you're also looking at, well, which items are sort of harder for some students and easier for other students, and that sort of thing. And once you kind of go through that process, it's very iterative. You know, I'm talking about professional assessment design now. You go through many iterations of this, and you're changing your assessments every step of the way. And once you get them right, then you're in a place where people can really make solid inferences. And the assessment argument is good and valid. That's really what testing is. You're making inferences to make decisions about someone's life. So we document, and I'm not going to go through this slide, but just to give you a snapshot of just how detailed we got in terms of documenting every single step of how we design these items. And these are all reusable. And these are all the kinds of things that you really need to know when you're making a good test. So what did the economics professors say they wanted their students to know and do? They wanted them to do cost-benefit analysis. They wanted them to think and reason with a supply and demand model. And they wanted them to use that same supply and demand knowledge to know about how you allocate scarce resources. And in biology, they wanted them to be able to predict outcomes using scientific principles, to analyze the news and health and environment, and to be a critical consumer of scientific research. So I wanted you to note again, going back to my initial point, this is what they value, how you apply the knowledge. So I'm going to also just give you a real quick overview of the different kinds of items. Our test had many different kinds of items. Do not come away from this talk thinking that I am putting down declarative knowledge. It's fundamental. It's a building block. I think my main point is I think sometimes it's overemphasized in a lot of the testing instruments in college today. But we had it in our test too, because we wanted to see, does it matter? I mean, if they're doing really well on the declarative items, are they going to do better on what we're calling the schematic items, going back to that flow chart? And then we had other items that were a little more complex. Can they link a few more ideas? And then strategic items. If we don't give you any hints about what principles to apply, and we just give you a real-world problem, can you pick the right ideas to apply? That's a strategic item. And we did the same thing for economics. We had the same structure. The main difference with the economics items is they really focus early on those procedures of graphing, you know, taking information from a table and putting them into a supply and demand graph. But they still have that application. So with that, I'm going to get down to our findings. And this is where we are doing our evidence testing. And just so, again, you understand in that refinement process, we're trying to understand more about, do we have the student model right? Are the items making sense? That's the task model. And is our scale good? That's the evidence model. So first I'm going to give you the study that we did on instructional sensitivity and the correlational, we had the same kind of data collection procedures for both of those, and I'm going to give you the results separately. But we had 296 students from a Bay Area community college. Half were in biology, half were in economics, and then we stratified them by experience, and you can tell by the karate levels what we were dealing with. And we gave them $175 to sit down and take 3 tests for 3 hours, ours and the 2 comparison studies tests. So on the instructional sensitivity analysis, this is where we did some statistical modeling to just see, okay, does it matter? You know, is there a variation according to how many courses you've taken, how successful you're going to be on these tests? We also looked at English as second language because our tests involved a lot of reading, and we were concerned that this might be a problem for students for whom English is a second language, and we found out non-significant. So here are the findings on instructional sensitivity. On the far left is our biology test. In the middle is our comparison domain test. And on the far right there, your right, is the critical thinking test. And those 3 bars, which you're looking at there, are on the far left side. Those are the beginning students. Those are the ones who've only had high school exposure to biology. And the middle bar in all 3 of those graphs is the students who have had just one, or 2 courses at the most. And then the sophomores, our sophomore experts, so to speak, are on the far right of all these tables. And so, or graphs. So what you see here is a nice slope upward. So they're getting better on our test and on that domain-specific comparison test, slowly getting better as they march through. So this tells us, hey, we're actually testing something that they're learning in school. Good. What's interesting, and this was a very interesting finding that we're not surprised to see it, but we weren't searching for it, is look at the critical thinking test. It didn't move at all, did it? And we all hear all the time, what's college all about? We develop critical thinkers, right? Well, psychologists actually have a kind of a skeptical view of this whole notion of critical thinking as a general concept. We learn to think in domains. We learn to think in contexts, and it doesn't transfer that well. So you're kind of seeing a little artifact of that phenomenon, I think. But there are a lot of people, when they're talking about accountability at higher ed, and there was a whole book about it called Academically Adrift. I don't know if anybody saw it. But essentially indicts the higher education field for not successfully teaching students to think critically. Well, as you can see, it doesn't really change that much from high school on, because what you're learning in college is to learn more about domains. That's what I would argue. That's why you're seeing these results. We saw the exact same thing in economics. Same thing. Sensitive for our test, sensitive for the comparison domain test, nothing for the critical thinking. Bob?
I just wanted to say.
By the way, this critical thinking test we were using, thank you, Bob, Oh, okay. He was saying that it's really quite a low point here in the talk because he's a college educator, and their mantra is to teach critical thinking in college. And these data show that they're teaching more about the domain, right, and not about critical thinking in general. Well, let me just make a couple more points on critical thinking. We used one of the many instruments that's out on the shelf right now for critical thinking. This is intercorrelated with all the other ones, just so you know. It's not like, oh, you used a really bad one. No, they're kind of all, and really when you look at the, what they're talking about, it's almost like logic. If I had to recommend how you teach critical thinking based on how they test it, I'd say go back to your logic and rhetoric courses. So what those boxes are showing you is there's a sort of a median score. There's a line in the middle of each of those boxes. And what that's telling you is that's the score that students got on our test if they were, basically they hadn't taken any biology courses yet. They only had what they learned in high school. That's the first bar. The second bar is when they had a couple of classes and their median score went up. And then when they had all the classes that they could take, then you see the median score is the highest yet. Is that clear? So then we looked at the correlational analysis to see what was going on among the scores that the students were getting on the different tests. And again, we thought we were testing something a little different. So we didn't think that we would be correlating with the domain test that closely. We thought we'd have a moderate correlation. And then we didn't think we'd have a super strong correlation with the critical thinking test. And in fact, that's what we found. And again, I don't know if there's a problem with seeing some of this, but you can see that it was a 0.52 correlation between our test, which is DSA, and the comparison biology test, which is test B. And then there was a 0.25 correlation between our test and test C, which was the critical thinking test. And you can see the sort of relation there. And we saw the same thing for economics. So this was confirming pretty much what we thought we were going to see, which is that we are doing something a little different. You know, it's not a one-to-one correspondence. We're like 0.52, 0.6 something. So we're doing something a little different from the existing domain tests. And we're doing a little bit of critical thinking, but not, that's really distinct from what we're doing. So now we're going to turn to another one of our tests, which is content validity. And this is very interesting. It really is where we sit down with experts and we have them look at our test items and our prompts and we say, what knowledge are we eliciting? And we got 4 professors. They sat down for 2 days with rating booklets. And those rating booklets include sort of a mix of our items. We had our test items, then we'd have another subset of a different test items, the comparison domain test, and then we had the critical thinking test. And we would cycle through those items. They were blind to which test they were looking at. And then we just had them look at the prompts and just say what knowledge is elicited. And this is how we had them do ratings. So there could be sort of simple knowledge that I described earlier. This is just the facts, just the little bits. Is this test item just eliciting a few, points of factual knowledge? Or is this test item eliciting a kind of, you're having to connect the dots, kind of relational knowledge? And is it simple, just a couple of points, or is it very complex with multiple points? And then what kind of reasoning would students need to answer the assessment task? Was it argument? Was it, were they doing sort of reasoning with the model, applying the model? And then we asked 2 other questions. We said, well, when do students learn this content in college? And is this important? And what for? Is it important for future study? Is it important for everyday application? And this is what we found. And I'm just going to, again, show you the graphic results here. And what you're looking at here on these 3 bars, the top bar is our test. The second bar is the comparison domain test. And the third bar is the critical thinking. So the one down at the bottom is the critical thinking. Now, you'll see there's a color code there. And what you'll notice on the critical thinking test, the chart on your left is asking them about, are we eliciting discrete little factoids? Okay? And what those colors are telling you, the critical thinking test is mostly blue. What that means is no, you're not eliciting any knowledge from the domain. And it's the critical thinking test. That makes sense. You see with the green and the red, our test and the comparison domain test, both of those tests are eliciting lots of little bits of factual knowledge. But the difference between the green and the pink, or the red, is the following. The green means we're asking about a lot of different points. We're not just asking about one point. So the comparison biology test was asking mostly about the one point. And this confirmed our hypothesis about what these tests really tend to be like. They're going straight toward the facts. That argument is further supported if you look at the other chart there on your right side, which asks them about relational knowledge. How much of the knowledge we're eliciting is actually asking people to connect the dots? So you see on our comparison test, there's a big blue line, and that essentially indicates that the raters thought, for the most part, most of those items were not asking for any connecting of the dots. Whereas in our test, the gold and the green and the pink are basically saying lots of dot connecting, okay? So that was biology, and this was a very nice finding for us that our design had actually worked, and we really were testing how well people could connect the dots instead of just plucking out a little fact here and there. I'm not going to go over this in tremendous detail, but simply to show you that when they scored the types of reasoning that we were getting in our test, you see the big pink bar there with our test on the top, and there's the little stumpy bars on the comparison test. That's just a sign that our items were eliciting more of different kinds of reasoning. The pink bar is, I believe, producing an argument. So they were getting an opportunity to produce arguments on our test items. Now, with the critical thinking, you see a big blue line, and that was basically analyzing an argument. Okay, so we found something very different in economics. Economics, it turns out, the test item that the test we were comparing ourselves to, is doing a pretty good job already of eliciting multiple kinds of knowledge and also asking people to relate ideas. So that was not what we expected to find, but there it is. They were doing a good job. And I'm going to now switch over to the reasoning. The one area where we were a little different, we added a little bit of value, is that you've represented in that gold bar there, which relates to producing an argument. You had more of a chance to produce or create an argument in our test than you did with the other economics test. And actually, one of the things that one of my economics experts said to me is that's a pretty important, that's a real contribution because they really value their students being able to argue.